Hello, this is Stephen Whitfield, a drilling contractor here at the 2022 IADC SPE International Drilling Conference and Exhibition in Galveston, Texas. With me right now is Steve Krase, co-founder of Hephae Energy Technology. Mr. Krase gave a presentation here at the conference on new generation geothermal wells and how the oil and gas industry can use this expertise to help make these wells a reality. Mr. Krase, thank you so much for joining me today.
Thank you, Stephen. Thanks for having me. I appreciate this.
So, in your presentation, you talked a little bit about this concept of the unconventional geothermal well and how that can be a critical factor in enabling geothermal everywhere. For those of us who might not be familiar with the term, can you describe what an unconventional geothermal well is?
Right. So the way I like to think about it is it's very much akin to oil and gas. When we transitioned from conventional oil and gas wells to unconventional oil and gas wells. In conventional oil and gas wells, we target oil and gas that's trapped in a reservoir above source rock. In the unconventional wells, we just go for the source rock. And up until recently, that was crazy. Right? In the conventional geothermal wells, the ones that are being drilled today, we target steam and we target hot water that's trapped in rocks, in reservoirs. In the unconventional geothermal, we don't target the fluid, we target the heat, right? And then we introduce the fluid into the system and we pull the heat out of the fluid that we've introduced into the system. So in a lot of ways, it's very much like the unconventional oil and gas transition from conventional to unconventional.
So you also talked about some of the challenges that the industry would face in sort of making these unconventional wells a reality. One of the things that you mentioned was the lack of downhole equipment that's rated above 200 degrees Celsius. Why is that particular threshold important?
Well, in geothermal, any type of geothermal activity, or any kind of when you're trying to produce electricity from heat, the hotter material that you're working with, whether it's the rock or the working fluid, the hotter it is, the better it is. We like to say hotter is better, and that's because the system becomes more efficient, right? You're able to generate more electricity with hotter water, hotter steam, hotter rock. You're able to get more energy out of the system, and you're competing with other renewables, like wind and solar, and so we have to be competitive with those two types of energy. And in order to do that, we've got to be hot. We've got to go hot, hot, hot.
Something really interesting that you brought up in your presentation as well was the Venus rover project, and you sort of used that as an intro into discussing how the oil and gas industry can learn from other industries like aerospace to help sort of bridge these gaps that you were talking about in the unconventional geothermal well development. So, what are some of the things that the industry can learn from other industries here?
Well, this might be surprising, but when I started in the industry in 1984, working on downhole measurement well drilling systems, that is, they tell you your inclination, your azimuth, and the direction that you're drilling. And in order to drill any type of a directional well, you need survey measurements. You need to understand where you are as you're drilling, and so you can plot your course underground. Now, in 1978, when the first commercial MWD system was developed by Teleco Oilfield Services in Meriden, Connecticut, which is who I went to go work for in '84, all of that technology came out of aerospace. Because guided missile technology, you need to know the same thing. You need to know exactly where you are at all times. Now the challenge, so we've leveraged off of aerospace technology always in oil and gas. The difference back then is that the guided missiles that were being deployed at that time didn't need to be hot, high shock, high vibration, and so it fit very well for downhole drilling. And we were able to leverage off of that technology from a ruggedization from the ruggedization standpoint, and temperature wasn't that important. Now, we've kind of what the 175C, 185C limit for aerospace components and automotive components, which is another industry that we leverage off of. But in order to get above that requires a completely different approach. Most of the electronic components are plastic packaged. It's not going to work at above 200 degrees C. Those plastic packages are just not going to cut it. And so when you look at what's going on with NASA trying to put a rover on the surface of Venus, that's 500 degrees Celsius. So now you've got a whole industry that is working on trying to supply NASA with the components required to get that done. And we intend to leverage off of that, just like we did in the late 70s and early 80s. We're going to leverage off of that technology development because the geothermal industry is just not big enough to just do it on our own. The amount of research and development that has to go in developing components to go to 500 Celsius, we just don't have the resources to do that. So thankfully NASA is gonna we're gonna go find out what's on Venus.
And lastly, you said that geothermal presents an opportunity for the oil and gas industry to realize a new class of drilling rig. And I have to ask about that. Can you elaborate on what this new class of drilling rig is? Where are we in getting there?
Well, that's a good question. And the answer, in my mind, this is the challenge. Temperature, for one. You're dealing with super hot fluid at the surface. Now, we're drilling hydrothermal wells today. I get that, and people are dealing with those temperatures. We're talking about temperatures of 200 C, roughly around 200 C. But when you start to go to supercritical temperatures like 400 C, 500 C, even higher than that, you need to look at how you're going to handle that fluid at the surface, whether it's blowout preventers, or safety equipment, continuous circulation material, continuous circulation equipment, automation. And the other thing that we're finding out is not only is hotter is better, but the more volume is better. So the bigger the hole, we want to go as deep as we can, as hot as we can, and bring back as much hot fluid or steam back to the surface as we can. And in order to do that, you've got to be able to have a significantly high string rate than is available on a lot of the land rigs today. You're looking at completions that are more akin to what's going on in the deep water, and those rigs don't exist on U.S. land today. Now, if we're going to be successful, like I think we are, in developing geothermal resources around the globe, hopefully we don't have enough rigs anyway. So we're going to run out of the regular drilling rigs anyway, we hope, and that's the goal.
Well, Steve, thank you again for taking the time to speak with us today. Geothermal is a hot topic in the world of drilling, literally in the world of drilling, and a lot of people are trying to figure out how we're going to make this more of a reality. So thanks for providing the insight.
Thanks, Stephen. I appreciate it. Thanks for taking the time. It's a pleasure to meet you.
And thank you for visiting Drilling Contractor.